Hi, welcome. So we've got a question here, and let me just quickly share my screen so that we can start the question, right? So this is what it is. Yes, here I am. Now the question says that there's a circle and there are two equal chords in that circle, and both the chords are intersecting each other. And we need to prove that the segments of one chord are equal to the corresponding segments of the other chord, right? So let's first of all understand what exactly it means as far as this question is concerned with the help of this figure, right? So first let's mark the center. The first things first, so we mark the center here. That's the center of the circle, and this is suppose the first chord. So now they are talking about the two chords, and suppose we have got the second chord which is like this, and we mark it, you know, like A, B, and say this is P and Q. And the point where we these two chords are intersecting each other, we will mark it as M, and the center of the circle is say O, right? Now, what we need to prove is the segments of the chords. So we have got two chords. So for chord BAB, the segments are A, M, and the other segment is B, M. And similarly for PQ, that's P, M, and that's B, sorry, that's QM. Yeah. All right. So what we need to prove is that the corresponding segments, that means AM is equal to BQM and BM is equal to PM. This is what we need to prove, right? Now, let's start this. And the first thing which we will do in this question is that we will draw two perpendiculars from the center. One perpendicular on the chord PQ and the another perpendicular on the chord AB, right? So these are the two perpendiculars, and let's mark them as, uh, we can mark them as C and D. And these two are 90-degree angles. Now, with the help of the theorems of the chords, we already know that if the perpendicular, if, you know, we can say that since OD is perpendicular to PQ, then we can say that PD is equal to QD, right? That's the understanding. That's what we understand from the theorems. Similarly, we can create the relationship for the other chord also, and that is like since OC is perpendicular to our chord AB, so we can say that AC is equal to BC, right? Now these are the two relationships which we have established here, and we will use them further. Now let's now also connect M with O. So we have got two circles, two triangles here, and we are going to examine these two triangles. So the one triangle is, let's take them as triangle OCM. Yeah, OCM. And the other triangle which we have taken here is, let it be ODM. Okay. Now here what we can say is that OM is equal to OM because that's the common side in both the triangles, and also we can say that OC is equal to OD because that's because equal chords equal chords are always equidistant from the center of the circle, right? So we can say that OC is equal to OD. And the third property is that angle OCM is equal to angle ODM, and that's 90 degree. So having said that, these three properties, this one, this one, and this one, we can say that these two triangles are basically congruent to each other. And if these two triangles are congruent, then we have this relationship here, and which is MC is equal to MD, right? So that's the important relationship which has come, and we will be using it further in this question, right? Now, since we already know that AB is equal to PQ, right? AB is equal to PQ. That's already given in the question. So what we can write is like we can write instead of AB because we have this relationship that AC is equal to BC, right? So we can write that it's 2BC, right? AB can be written as 2BC because C is the midpoint. So 2BC from here till here, the double of 2BC is the entire AB, right? Similarly for PQ, we can write it is 2PD, right? So, uh, yeah. So now here we can say that BC is equal to PD. Now BC can be written as BM plus MC. Okay. Yeah. BC plus MC, and similarly this PD is can be written as PM plus MD. So I'm writing like PM plus MD. Okay. Now with this relationship, right, we know that MC is equal to MD. So we can easily strike them off, right? And finally we get BM is equal to PM, right? So our this relationship is taken care of. This is proven, right? Now let's focus upon the other one, like AM is equal to QM, proving that. So for this, what we'll do is we'll again start with AB is equal to PQ, right? Or what we can write is that you know we can write 2 we can write 2BC is equal to 2PD, right? And yeah, and here what we can do is BC can be written as BM BC can be written as something different, and what we'll do is we'll simply write it as AM. BC is equal to, what we can do is then we can write BC is equal to as AC, and instead of PD what we can then write is QD, right? So here AC can be then written as AM minus MC. Similarly, the QD can be written as entire QM, right? QM minus DM or MD. Now again, with the help of this relationship, we understand that these two are equal, and hence we strike them off. And when we strike them off, we get AM is equal to QM, right? So this is what we have proven, and this is what we had to prove, right? So this is how these two segments are equal. And we can say that the corresponding segments are equal in this case. So keep watching these videos, and I'll be coming up with more videos on circles tomorrow on this, right? Thank you so much. Have a nice day, and bye bye.